What's going on, friends? Testing is one of the skills that can make you stand out and skyrocket your engineering career. In this course, I'm going to explain what you need to know about testing. We are going to cover the rationale behind writing automated test cases, the Pytest framework, the 3A principle, mocking, parameterization, and much more. Together, we are going to write automated test cases for this CLI project. A special bonus to my subscribers is this complete Pytest book I'm working on. You will be the first ones to access this detailed book. If you haven't subscribed to the channel, kindly do so now. To follow along, I recommend you visit this URL on the screen to download the CLI project we are going to test. The CLI project reads and validates employee information in a file and then send email to all the employees. So as you learn a concept, you apply it immediately by writing test cases. Imagine being told to board a jet that has never been tested. Would you do it? Absolutely not. The same applies to software. You wouldn't want to use a software that hasn't been tested. Testing can come in different forms. For a front-end engineer, this might involve doing 1 or 2 clicks here and there to ensure that a feature is working as expected. For a back-end engineer, it might involve testing if an API is working using tools like Postman, Swagger, and so on. The 2 examples I mentioned are known as manual testing because they involve human intervention. Manual testing works, but it becomes a bottleneck as the software grows bigger because every time we introduce a new feature, we need to manually test all the existing features to ensure that nothing has been broken. Automated testing involves writing code that tests other code. This means you have a piece of code performing a particular function, and then you write another piece of code to test or check if the first code is working or behaving as expected. We are going to focus on unit and integration testing in this video. Unit test ensures that a specific part of the software works as expected. Integration test ensures that combined parts work as expected. Pytest is a popular software testing framework for Python that makes it easy to write simple and scalable tests for your code. There are other testing frameworks such as Node2 and unit test, but Pytest outshines them. Pytest is easy to read and write, powerful and scalable. It comes with cool features like parameterization, fixtures, and so on. The first step is to install Pytest. I'm going to create a virtual environment by using this Python command, python 3 -m virtual env. So now we have a virtual environment created. Next, we need to install Pytest and any other libraries we might need. Pip install -r requirements.txt. This command installs all the libraries listed in the requirements file. Pydantic is widely used for validations. It is used to check if data conforms to a defined structure. Whenever you are writing automated test cases for your application, it is highly recommended that you separate the test cases from the actual application codebase. To achieve that, we are going to create a new folder named tests. This folder will contain the test cases for this CLI app. I'm going to create a new file named test_validators.py. Let's make this directory a package by creating the init file. Let's start with this simple example, def add x, y, return x plus y. This function returns the summation of 2 numbers. If we intend to do a manual test for this function, we would need to call it a couple of times and inspect the results. Let's call the function add 2, 0, 5, 6, 5, and 5. Let's print the results on the screen. Print. Now we can execute the program. By manually inspecting the outputs printed to the screen, we can say that this function works as expected or not. Automated testing involves writing another code to check that your code works as expected. The code you write to check if another code is working as expected is called a test case. Now let's create our very first test. Def test underscore add. The convention when naming a test function is that it should start with test. Then you can now mention the name of the function which you want to test. In this case, we want to test the add function. When Pytest is searching for test cases, it looks for files following these two patterns: tests.py and _test.py. The first pattern matches a file starting with test underscore, then followed by any number of characters. This could be 0 character and ending with .py. The second pattern matches a file starting with any number of characters. This could be 0 character and ending with _test.py. As you can see, the test file we created starts with tests and the name is validators. Writing a test case is simple once you understand and follow these 3 phases. The first phase is the arrange phase. Before you start writing a test case, you need to identify if there is any initial condition needed for the code in question to work. For instance, if you want to test that a user can log in to a system, then that user must have registered. So in the arrange phase for such a test, you need to first create a user. For this add function, we need the numbers which we want to add. So in the arrange phase, we can create the numbers. Number 1 equals 10, number 2 equals 6. We are setting up the initial conditions for the test. I hope you are noting down the phases. The next phase of an automated test is the act phase. This is where you need to call or invoke the function that you want to test. The goal is to observe the outcome of the code being tested under the specific conditions you might have put in the arrange phase. In our case, we need to call the add function, which is the function which we want to test. Add num1, num2. Let's assign the summation of the two numbers to a new variable, results equals. The final phase, which is the third phase, is the assert phase. In this part, you want to verify the result of the code execution against the expected outcome. You, the engineer, already know the expected outcome of this code. So you want to check if the code produces the expected result. We need to use the assert keyword to do that. Assert results equals 16. The assert keyword checks if a condition in your code returns true. If this part of the code does not evaluate to true, then the test will fail. The next step is to run the test. To run the test, we need to use the Pytest command on the terminal. From which directory or folder do we run the command? Should we run it inside this test folder or in the root directory? Whenever you run the Pytest command, Pytest will run all test cases in the current directory and its subdirectories. So we can decide to run the test in this test directory or in the email starter directory. Let's try that out. Pytest. This shows that one test passed in 0.03 seconds. The test can be found in this directory. The green dot indicates that the test passed. Let's see how a failed test looks like. So we can create another test function. Test add, let's call it new, 5. The result is, let's say, 12. The summation of 5 and 5 is expected to be 10. So this test is going to fail. Let's run the test again. As you can see on the screen, 1 failed, 1 passed. This line triggered the failure. Assert 10 equals 12. The letter F shows that the test failed. Now you have the understanding needed to start writing test cases. Let's move on. Alright friends, this project automates the process of sending emails to employees. We have a list of employees in a CSV format. In this reader.py file, we are reading and validating the contents of the CSV file. All the validators are put in a separate module, which is validators.py. In this email module, we are sending an email to each of the employees. Let's execute the program Python 3 main.py. Email sent to the email. I'm going to open my email to see if the email was delivered. Great, we can see the email in the email. The only external dependency you need if you want to run this program is the email service. I used Brevo. On the Brevo dashboard, you can create a new API key. Once you have the API key, you need to put it in the .env file, which is this file, the environment variable. Make sure you don't expose this key to the public. Let's start writing unit tests for some of the validators we have in this module. A unit test checks if a specific function or part of the application works as expected. We need to import the functions from email sender.validators, import validate phone number, validate CSV headers. We can now create our first test validates phone. This regular expression matches a phone number starting with 0 or +234, followed by a 10-digit number. We are going to write a test to check if this function works as expected. The first phase when writing an automated test is the arrange phase. In this phase, we need to figure out any dependencies needed for the test. In this test, we need to have a phone number which we want to test. Let's declare a new variable to hold the number +234. Let's add additional 10 digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The next phase is the act phase. In this phase, you need to take an action by interacting with the software. So let's call the validate phone function validate phone. Then we need to pass the number to it. The function returns a Boolean data type. Let's assign the returned value to a new variable is valid. The final phase is the assert phase. Assert, we need to use the assert keyword is valid. You, the engineer, know if this number is valid or not. So you want to check what you know against what the code produces. If this part of the code evaluates to true, then the test would pass. Let's run the Pytest command, Pytest. It works as expected. It is highly recommended that you test your code against a couple of inputs to see how it behaves. So we are going to use another phone number. Let's create another test case for that. Now, in this case, let's say the number starts with 0. Then let's add 4 digits, 1, 2, 3, 4. The expected output from this function should be false because we don't expect this number to be a valid number. So if I were to run the test again, you would see that this test will fail because this is not a valid number. Let's run the program again. As you can see, the second test case failed, which is this test case. We need to update the test case to be assert not valid. Now let's execute the program again. This shows that the 2 test cases passed. Let's use another valid number starting with 0_1. Then the number should start with 0. This number is a valid number because it starts with 0 followed by 10 digits. Now let's execute the program again to see the output. Great. The next function on the list is validate CSV headers. This function checks if a list has these 4 items: name, email, title, and phone. Let's create a new test case, test_validate CSV headers. In the arrange phase, we can provide sample headers. Let's provide a sample headers equals a list, email, name, phone, and title. The order of the items in this list does not matter. In the act phase, we need to call the actual function we want to test. Let's say validate CSV headers. Then we need to pass the headers to it. This function returns the missing column. So we can say missing columns equals a new variable This function returns the missing columns. Since we know that there is no missing columns in this list, the returned output should be an empty list. So we can say assert missing columns equals an empty list. For each headers in the expected headers, if the header is not in the CSV headers, then it should be added to the new list. Now let's execute the Pytest command again to see the output. The test passed, but all the previous test cases were also executed. To restrict Pytest to only run a specific test, then we can make use of a command line flag, Pytest-k. When you pass a string to -k, it only runs test cases whose name contain the string. So the name of the test is validate CSV headers. Now let's try that out. As you can see, only one test was executed, 1 passed, 3 deselected. To see more information about the test, we can use -v. Let's execute the command. We can now see the actual name of the test, test validate CSV headers. Let's write another test for the validate CSV headers. This time we are going to use an invalid headers. Def test validate invalid CSV headers. So we can say headers equals phone and title. Missing columns equals validate CSV headers. Then we need to pass the headers. Assert missing columns to be equal to email and name. Remember that we need name, email, title, and phone. Now let's run this test. We need to use the Pytest command. Then let's paste this. As you can see, the test failed. It raised an assertion error. Assert name email equals email and name. The test failed due to the order of the items in the list. We can make use of the sorted function to sort the items in the list. Let's use the sorted function. Sorted. Let's also sort this list. Sorted. Now let's run the program again. Great, the test passed. If you take a look at the previous test cases we wrote, there are a lot of repetitions. The only thing we keep changing is the parameter. We used a different parameter here, a different one here, and also here. The same applies for the validate CSV headers. Parameterized testing is a technique to run the same test logic with different inputs. We need to import Pytest to use parameterization. Let's say import Pytest. Now let's rewrite the validate phone test to use parameterization. I'm going to copy the first test case. Then I can comment out this part. We need to use it as a decorator, pytest.mark.parameterized. The first argument we need to pass to parameterized is the name of the arguments that can have multiple values. In this case, phone number can have multiple values. So we need to put the phone number in a string, phone_number. The output of this function is dependent on the phone number passed to it. So this means the output can also have multiple values. So let's say outputs. The next thing is to provide the actual values for phone number and outputs. The actual value needs to be in an iterable, such as a list. The first value is 080 and the output should be false because 080 is not a valid number. The number should be 0 followed by 10 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the output should be true. It should be a valid number. Let's also use another value. Let's say plus 234 followed by 10 numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This also should be true. Plus 234 followed by 8 numbers 1, 2, 3, 4, 5, 6, 7, 8. This value should be false. It shouldn't be a valid number. The first time the test runs, it uses these values. The second time, it uses these, and so on. Now, the argument names, also known as parameters, can be used in the test function. So we can say phone number, which is the first one, and the output. We no longer need this value, which is on line 27. Let's pass the phone number to the function. Then we can say tests underscore results. Then we need to assert that the test results is equal to the output, which is the intended output. We can now remove this line completely. Now let's run this test again. As you can see, the same test ran with different inputs. Let's see how we can utilize parameterization for the second test function. So let's comment out this part of the code. First of all, we need to say at pytest.mark.parameterized. We need different values for headers. We can include it in parameterized. Also, we need different values for missing columns. The missing columns is dependent on the parsed headers. Let's put this in a list. For the first, let's say phone, title, and the missing columns is expected to be email and name. Let's try out another value. The headers is name, email, phone. The missing columns is expected to be an empty list. Let's try out one more example. When the headers is an empty list, the missing columns should be this. We don't need this line 38. We need to pass the headers, which is this parameter, and also the second parameter is the missing columns. The headers is passed here, and let's say the test result equals this. Now we need to say assert test results to be the missing columns. Missing columns. Now let's run this test case. Test validates CSV headers. We omitted the sorted function. Sorted. Also, let's sort the values. Now let's run the test again. Great, all the test cases passed. Pytest provides a configuration file which can be used for customization. We've been using the -v flag to see more information about test cases. If you use the print statement to print something on the screen in your test, Pytest will not show it on the screen except if you use the RA flag. Let's try that out. Let's say print running. Let's run the test again. As you can see, we couldn't find the text from the print statement on the screen. Now let's make use of the RA flag -RA. Let's run the test again. As you can see, we now have running the test printed on the screen. We don't want to keep repeating all these flags when we run the test, so we can create the pytest.ini file in the root directory. Touch pytest.ini. In this pytest.ini file, we can say adopt equals -v -RA. Adopts refers to extra command line options that Pytest should use. There are other arguments you could use. Now let's run the test again without the flags. Let's see what happens. No section header defined. So we need to use the Pytest header, which is this Pytest. Now we can try it again to see the output. Great, it works as expected. We now have outputs from the print statement on the screen. Alright friends, the first assignment is to write a test for this function, validate CSV length. Let me know if you are able to do that. If you haven't subscribed to the channel, kindly do so now. Next, we are going to test the read CSV function. Given a file, it returns a list containing instances of the person class. The person model is a Pydantic model. Pydantic is used for data validation. If Pydantic is not able to instantiate this class, it raises a validation error. Let's create a new file named test_reader. Test_reader.py. We need to import the read CSV function since that's what we want to test. From email sender.reader import read CSV. Let's create the first test read valid CSV. In the arrange phase of this test, we need a CSV file containing some data. Remember that we need to pass a file to this function. Within this test, we need to create a file. We can make use of the named temporary file from the temp file module. Let's import that from temp file, import named temporary file. Let's create the file with named temporary file as temp file. There is a couple of arguments we can pass to this function. The suffix of the file to be created should be .csv. Suffix equals .csv. We can also pass delete equals false. This means we don't want this file to be deleted when it is closed. If you want to know more about this function, check the link below for the documentation. Now we want to create a CSV writer. Writer equals CSV. We need to import the CSV module. Import CSV. CSV.writer. Then we need to pass the temp file. The limiter is comma, quote character, quoting CSV dot quote minimal. Let me format the document. Now we want to write some rows into the CSV file. Write row. The first row is going to be the headers: name, email, title, phone. Let's write another row into the CSV file. The second row, the name is Ray. The email can be hi@ridwanray.com. The title can be engineer. The number should be a valid number 0, followed by a 10 digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's write another row. The value can be read1, and the email can be mail.ridwanray@gmail.com. Let's say the title is engineer and the number. Finally, we want to return the name of the file, tempfile.name. The name of the file is the same as the path of the file. We will likely need another file later, so it makes sense to put this functionality in a separate function. Let's create a separate function that returns a valid file. Let's say def make valid CSV file. This function returns the path of the created file. The name of the file is the same as the path of the file. Now let's make use of the file in the test. We can create a new variable called file equals make valid CSV file. Let's call the function. Now this function returns a string, which is the path of the file. Remember that we are still in the arrange phase. The next phase is the act phase. This is where we want to call the actual function, which is read CSV. Read CSV. We need to pass the file test underscore results equals read CSV. Read CSV returns a list of person. We want to check if a list data type is returned. Asserts is instance test results is a list data type. Also, the number of employees in the CSV file is expected to be 2. Asserts length of test results equals 2. Let's print the name of the file on the screen. Name. Remember that we are writing into the temporary file, so the mode should be write. Mode equals write. Now let's run the test. Pytest -k, the name of the test. The test passed. Let's look for the file that was created by the tests. I'm going to open up a terminal. We can say cd, the root. Now we can navigate into temp, which is the temp file. The name of the CSV file is 2v4c. Let's look for the name 2v4c. Now let's see the contents of the file. Temp. As you can see, this is the content we wrote into the file during the test. The file created was not deleted after the test. Let's delete the file from the Python program. We need to use the OS module to remove the file. Let's import OS. Imports OS. We can say os.remove. Then we need to pass the name of the file, which is file. The remove function deletes a given file. Let's run the test again to see what happens. We have a new file and the name is pyest. Let's look at the temp directory to see if the file can be found. As you can see, the CSV file could not be found because we deleted it after the test. We've used a valid CSV file. Let's make use of an invalid CSV file. Let's create another function for that. Let's call it make invalid CSV file. We can just use a role. Let's provide invalid email address, hi@readonray. The expectation is that Pydantic will raise a validation error because of this invalid email address. Let's write a new test for invalid CSV file, def invalid CSV file. So we can create a file. The file is going to be an invalid CSV file, make invalid CSV file. Then we need to make use of the read CSV. We need to pass the file created, result equals this. When we call read CSV for an invalid file, a validation error will be raised because Pydantic will not be able to instantiate this class. Now we can use Pytest to check or assert that a validation error is raised. Let's say with Pytest, we need to import Pytest, import Pytest. With Pytest.raises, then we need to pass the exception. The exception is validation error. From Pydantic, import validation error. We are using Pytest to assert that when this function is called, a validation error is raised. And finally, we need to remove the file os.remove. The name of the file. Now let's run this test invalid CSV file. Great, the test passed. This means a validation error was raised. So now is a good time to explain fixtures. Fixtures are reusable functions for your test cases. Most times you use fixtures in the arrange phase, though it could also be used in the act phase. We can tell Pytest that a particular function is a fixture by decorating it with pytest.fixtures. So we need to say at pytest.fixtures. This means make valid CSV file can now be used wherever we need it. So you can pass it like a parameter. Let's make use of it. We can pass it here like a parameter. When Pytest sees this fixture, it calls it automatically for you. What is returned by the function call can now be referenced as the name of the function within the test. In short, Pytest automatically calls this fixture for you, and the returned value from the fixture call can be accessed as the name of the fixture within the test. So this means we can pass what is returned by the fixture into this function, which is read CSV. Also, we can pass it to the remove function. Remember that this fixture returns the path of a file. Now let's run the test again. Read valid CSV. It works. As you can see, the returned value from the fixture call is this. We can also turn the second function to a fixture at pytest.fixture. So now we can make use of the name of the fixture. So we need to pass it like a parameter. So Pytest will automatically call it. Then we can pass the returned value from the fixture to this function, which is read CSV. We can also pass it to the remove function. Now let's run the test again. Test invalid CSV file. It works as expected. Fixtures are reusable functions. When Pytest sees a fixture as a parameter, it automatically calls it, and the returned value from the fixture can be accessed within the test body through the name. Fixtures are generally put in a file named conftest.py. When you put them in conftest.py, then you can make use of them in different modules. So now let's create a conftest file. Touch conftest.py. We can move all the fixtures into the conftest.py. Let's copy all the fixtures. Let's put them in the conftest.py. So we need to import a couple of modules. Import Pytest. From temp file, import named temporal file. We also need to import CSV. Import CSV. Let's go back into the test file so we can remove all these unused modules. Remember that all the fixtures are now in conftest.py. So let's run the test again. Great, it works. The right directory to put a conftest file depends on where it is used. Conftest put in this folder can be used in this folder and its subdirectories, but it cannot be used in a directory which is above these tests. A fixture is not only used to set up the data needed during the test, it can also be used to clean up resources after the test. This could include removing files created during the test, disconnecting from the database, and so on. If we want some code to run after the test, then we can make use of the yield keyword inside the fixture. Let's make use of the yield keyword yield tempfile.name. When the yield keyword is encountered in a generator, the execution of the function is paused, and the value in front of the yield keyword is sent to the caller. When next the function is called, a generator is able to resume execution from where it paused. I have a video explaining generators and the yield keyword. Check the link below for the video. I'm going to print some text on the screen. Print before test. Print after test. Let's go to where this fixture is used. Test reader. Test terminates. Now let's run the test. Pytest, the name of the test, -k. As you can see, the part of the fixture before the yield keyword was executed before the test. The value in front of the yield keyword is sent to the caller. The next execution is coming from the test, and after the text was executed, the next part that ran was this code after the yield keyword. This means we can put cleanup operations after the yield keyword. So after each test, we want the file created during the test to be deleted. So we can put the remove function in the fixture. Let's go back into the fixture. Then after the test, we want to remove the file, which is this name. We can also do the same for the second fixture. That means we can yield the name of the file, and after the test, we want to run this function. We can remove all the print statements. We can also remove this part since it is now in the fixture. Now let's run the program again to see what happens. Great, the test works as expected. You can also pass the scope argument to the fixture. By default, a new instance of the fixture is created for each test function. This means the function is called every time it is requested in a test. If the scope is class, it is only called once for the test cases found in a class. We also have module, package, session, and function. The default value is function, which means the fixture is called for every function. I hope you now understand fixtures. Fixtures are reusable. A test can request more than one fixture at a time. A fixture can request other fixtures. The two fixtures we used were created by us. Pytest provides some built-in fixtures, which means you use them directly without creating them. Alright friends, we can group multiple test cases in a class. Let's create a new class test with CSV. Then we can now put these two functions within the class. Let's make the method an instance method, self. Let's do the same for the second. To run all the test cases in this class, we can make use of the class name, Pytest-k, the name of the class. As you can see, the two test cases found in the class were executed. Mocking is when you create a fake version of an object. If you take a look at the main module, it sends an email to each employee by using send email. The send email function depends on an external service to send the actual email. Also, remember that the cost of sending email is not free. Sending actual emails can also slow down the speed of the test. Let's create a new file named test send email.py. We want to test the send email function. First, we need to import the function from email sender.email import send email. We can put the test case in a class test send email. Test send email self. In the arrange phase of this test, we need an instance of the person class. Let's create the instance employee equals person. We need to import the person class from email sender.models import person. Now we need to pass a couple of arguments. The name is a string, let's say Anas, and the email, let's provide a valid email, let's say mail.ridwanray@gmail.com. Also, we can provide the title, engineer, and the phone 0 followed by 10 digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have an instance of the person class. Now we can call the function. We need to pass the employee. Before we run this test, We want to mock the email service because we don't want a real email to be sent to the user in test mode. That means we need to mock this function. This method is responsible for sending an email to a user. To mock an object in Pytest, we can decide to use mocker. This mocker is a Pytest fixture which can be used to mock an object. First, we need to install Pytest mock. Pip install Pytest mock. Let's put the library in the requirements file. I'm going to copy it. The version is 3.13.0. Now let's use it as a fixture in the test. Mocker from Pytest mock imports mock fixture. So the type of mocker is mock fixture. So we can say mocker.pash. Then we need to specify the location of what we want to mock. We want to mock this method, send transact email. Let's look for the location of this method, API instance. So this is the location of the method. Let's go back into the test. Now we can specify the location, and the name of the method is this, which is send transact email. So we are creating a mocked version of this actual method. We can set this to a new variable, mock send smtp email equals this. So before we call the function, we are mocking a method used in the function. Before we run the test, I want to print something on the screen. Let's say response equals this. Then we can now print response. Response. Now let's run the test to see what happens. Pytest-k, the name of the test. As you can see, this now returns a mocked version. Let me format the document. The next step is to check if this method was called with the correct arguments. We can say mock send smtp email dot assert. There is a couple of methods we can use. We are going to use assert called once to assert that the method was called once. We can also use assert called with, let's say, arguments equals the argument sent to the method. Let's take a look. So we pass an instance of send smtp email to the method. Let's make use of that from sib.models.send smtp email imports send smtp email, which is the class. The type of the argument is this. Then we can say mock send smtp email dot call args to retrieve the arguments. The call args returns a tuple. Let's print that out. Print args arguments. Let's run the test again to see the outputs. As you can see, we have a tuple returned. So we can pick the first elements at index 0. So we can say assert arguments dot subjects. Let's look at the subject of the email, which is email from Pytest. and assert arguments dot to, which is the receiver, equals. Let's take a look at how the receiver looks like. Okay, we can make use of this. So we need the employee dot email. Now let's run the test again to see the output. Great, it works as expected. Now let's test the main module, which is this module. Let's create a new file called test main.py. First, we need to import the module from main. Import main. Now we can create the function def test underscore main. Let's check the main function. In the arrange phase for the main function, we need a file. Let's go back into the test. Remember that we already have a fixture for creating a valid file, make valid CSV file. So we can make use of this fixture in the test. We can use the fixture by specifying it as a parameter. Main, we need to pass a file. Let's pass the make valid CSV file. If you take a look at this function, it also sends email. For each employee in the employees send email, we need to mark the email service because we don't want an actual email to be sent to the user. So we can make use of marker. Then the type of marker is from Pytest mock import mock fixture. The type of marker is mock fixture. I'm going to copy what we have in the send email. So let's copy this mock functionality. Before the actual function call, we want to mock the email service. Now we need the assert phase. Assert mock send email. Let's take a look at what we can assert. We can assert that this method is called twice. Let's go back to the test. Assert call count equals 2. Because we have 2 employees in the CSV file, these 2 employees, Pytest-k and the name of the test. Great, it works as expected. Pytest markers allow you to categorize and selectively run test cases. Let's say you want to run only the unit test cases, so you can decide to mark some test cases as units. We need to use at pytest.mark to mark a test, pytest.mark, then the custom name you want to use, units. Let's mark the second test case as units. The name is up to you. You can use any name of your choice. So it is possible to run only the test cases that are marked as units. Let's run the Pytest command, Pytest-m, which is for markers. Then you need to specify the name of the marker. So let's run the test. Only the test cases marked as units were executed. Sometimes you may need to skip a test. Skipping prevents test cases from running. We can use the built-in skip marker to skip a test. At pytest.mark.skip, then we need to provide a reason. Let's say to be tested later. We are also going to skip the second test case. Now let's run all the test cases. As you can see, the 2 test cases found in the test validators were skipped. We can use this command to check all the built-in markers in Pytest. dash markers. We have all the built-in markers: skip, skip if, exfil, parameterize, and so on. So here is the question: must I write test cases for my project? You should definitely write test cases. Writing test cases increases your confidence in the codebase. I hope you got a value in this video. Kindly like, comment, and subscribe. Thanks.